everyone, I hope you are doing well. In the previous video, I told you about that particularly difficult exam. Well, in my family, we had a word for that feeling. We called it a sum. And for the non-initiated, I will clarify. Sum means simply poison. And that gave me an idea. We're going to rank these videos together by sum level, a scale from 1 to 10. Some videos will be easy, others will hurt. For this one, I'd give it a 3 out of 10. Accessible, but hold on, because we are going somewhere unexpected. In this video, we will talk about the power of proteins to form emulsions and foams. But let's start with something simple. Let's talk about water. Do you remember? So it is a liquid. A liquid is a state where molecules are connected in a certain way, not too tightly bound, not completely free. That balance gives water its properties. Now, if you add sugar to the water, it disappears. It dissolves perfectly. That's a solution. Everything is homogeneous and uniform. If you add milk powder instead, it's a different story. The proteins don't dissolve perfectly. They disperse without truly dissolving. That's more a suspension. And if we enter the real complexity of food systems, where we have lipids, carbohydrates, proteins, it gets too complicated. So let me take you somewhere you might already know and maybe find fascinating. I want to talk to you about Cédric Grolet, the world's best pastry chef in 2018. He has 13 million of Instagram followers, lines forming hours before his shops open. His specialty is called trompe-l'œil. There are pastries that look like real fruit with unsettling precision. And his most famous creation, the one that started it all, is le citron, the lemon. He developed it at Le Meurice, the Parisian Palace hotel, where he has worked since 2012. On the outside, it's a lemon, textured, glossy, perfectly yellow. You hold it in your hand and you're not sure. You cut it, it opens, and there it is, a liquid of citrus core, acidic confit, candied zest, and an airy mousse. It's delicious. Now, you might be wondering what Cédric Grolet has to do with the video about proteins. The answer is simple. He is a genius of emulsions and foams. He has perfectly understood these systems and how to play with them. And yes, pastry is chemistry. To understand what Cédric Grolet does, we first need to understand a fundamental phenomenon. Take a bottle of salad dressing sitting in your fridge, turn it upside down, shake it, it mixes. Then, after a certain time, it separates. Always, inevitably. The oil floats back up, the vinegar sinks. But why? Because these two liquids don't want to touch each other. There is a tension between them, like an invisible skin keeping them apart. In science, we call this interfacial tension. It's the energy cost of maintaining contact between two phases that repel each other. You can see the illustration here, where I show the vinegar and the oil with the droplets that are formed after shaking. Now imagine a mediator, someone who speaks both languages, waters and oils, who position themselves at the boundary between the two and says, okay, we coexist. That's exactly what protein does. It has one part that loves water, that we call hydrophilic, and one part that flees water and prefers fats, and that we call hydrophobic. This dual nature is called amphiphilicity. From the Greek, amphi means both. The protein naturally positions itself at the interface, and in doing so, it lowers the interfacial tension. I have an important note. In real food systems, proteins are not the only molecules that play this role. We have lipids, polysaccharides. Many molecules can position themselves at these interfaces. For clarity, this series focuses on proteins and their role. In other words, each oil droplet ends up surrounded by a shield of proteins, heads toward the water, tails into the fat. The emulsion holds. You can see it at this scheme where we see the fat and the water with the proteins at the interface. When you shake it, we see clearly the oil droplet surrounded with proteins. Now that we explained this phenomenon, let's return to Cédric Grolet's lemon. Inside it, you have foams and emulsions. Each of these textures relies on the same principle we just described. Foam or emulsion, same principle, same player, the protein. What is a foam? It is an air dispersed in a cream. The dairy proteins coming from the ingredients as dairy cream or milk, so the caseins and whey proteins, position themselves around the air bubbles, lowering the air liquid interfacial tension. The bubbles hold, the foam is light and airy. What about the cream? It is an emulsion, so fat droplets in an aqueous phase, stabilized once again by proteins. When Cédric Grolet assembles his lemon, he works with these balances with extreme precision. Too few proteins, the foam collapses. Too many, the texture becomes heavy. It's not a magic, it's chemistry. That brings me to a question you may never have asked yourself. How do researchers understand those systems and see what's happening at the interface? We are talking about zones of just a few nanometers wide, a millionth of a millimeter. Impossible to see with naked eye, even with a standard microscope. And yet, understanding these interfaces is the key to designing better emulsions, better textures, and better foods. The answer is that they use sophisticated and complementary methods. And that's precisely what I will be exploring with the researcher who works on these very questions. Very soon in this series, you will see how we go from the lemon at Le Meurice to a research laboratory. So stay tuned. Now that we talked about those phenomena that are called in science food physics or dispersed systems, there are 3 points that I would like you to take away. The first point, an emulsion is two phases that repel each other due to interfacial tension. Without an emulsifier as a protein, they always separate. The second point, the protein is a natural mediator. It is amphiphilic it lowers interfacial tension and stabilizes droplets or air bubbles. The third point, high-end pastry is applied physical chemistry. Cédric Grolet masters systems that researchers are still studying. Now that I finished all the explanation, do you agree with the score of 3 out of 10 for this video? Let me know in the comments. Thank you all and see you soon.